In the previous video, we created a left Riemann sum calculator, and in this video we're going to extend this to a Riemann sum calculator that lets you choose where you want to evaluate it. Before we begin, we need to discuss the parameterization of an interval. Suppose that we have the interval CD on the real line. We want to find a way to represent all the points on this interval using a parameter t, where t is a value between 0 and 1 inclusively. In other words, we want to pick a value of t on the interval 0 to 1 and end up with a corresponding point x on the interval CD. There's a well-known formula for this, which is x equals c plus t times d minus c. We can easily see that this has the following properties. When t is equal to 0, x is equal to c. When t is equal to 1, x is equal to d. And as t increases linearly from 0 to 1, x increases linearly from c to d. We will use this formula for each of the subintervals in order to pick out the point at which we are evaluating the function. Let's return to the general setup. We currently have a function f defined on the interval ab, which has been broken up into n subintervals. We're going to introduce some additional notation to this diagram. We will label the edges of the subintervals x sub I, starting with x0 on the far left and ending with x sub n on the far right. This means that the kth interval will be the interval from x sub k minus 1 to x sub k. Next, we will introduce the parameter t and its interval 0 to 1. This parameter controls the points x sub I star. The position of x sub I star corresponds to the position of t using the representation we just discussed. So as t takes values from 0 to 1, each x sub I star takes values across its own interval. These points correspond to where we will evaluate the function to get the height of the rectangles. Notice that when t is equal to 0, we get a left Riemann sum. When t is equal to 0.5, we get a midpoint Riemann sum. And when t is equal to 1, we get a right Riemann sum. With this notation in place, we are ready to work on the spreadsheet. We will continue to use the function f of x equals 4 minus x squared with n equals 4. Instead of deleting all of our previous work, we will just update the spreadsheet that we have. We'll first delete all of the extra rows, and then we'll restore the correct function, and lastly we will fix the input parameters a, b, and n. This is where things were at in the last video before we started changing things at the end. We want to add the parameter t into our parameters on the top left. To keep the space below the parameters and calculated values, we can select these cells and drag them down a row. Google Sheets is smart enough to automatically update the formulas so that they follow the cells. This means that all the references for delta x will remain intact. We now have an extra row where we can add the parameter t, which we will set equal to 0. We now need to add a couple more columns to our spreadsheet. We will put these to the right of the index column so that we will have all the basic rectangle information together. To do this, we highlight the two columns to the right of the index column, right-click, and select Insert Two Columns Left. The first of these new columns will be x sub I minus 1, which is the left endpoint of each subinterval. We already know how to do this because this is what we did to get the x sub I star in the previous videos. The first value is a, and we will reference the parameter for this. Then the formula is the cell above plus delta x, and then we can autofill that down. The other new column will be x sub I, which is the right endpoint of the subinterval. The first one of these is the left endpoint plus delta x, and then we can follow the previous pattern of adding delta x to the cell above and autofilling downward. Notice how the right endpoint of one row is equal to the left endpoint of the next row. This is a quick check to ensure that our formulas look right. We now need to update the value of x sub I star. To do this, we will use the formula we had discussed at the beginning. The formula is left endpoint plus t times the difference of the endpoints. Make sure that you lock down the reference for t. After we type out this formula in the first row, we can autofill that downward to get the rest of the rows. At this point, there is no need to make changes to the other columns. Once we have the x sub I star calculated, the next column automatically takes it and plugs it into the formula, and the column after that automatically calculates the area. And so we're already done with this update. In this case, we have t equals 0, so that it's calculating a left Riemann sum. To make it calculate the right Riemann sum, we would set t equal to 1. Notice that the areas of the rectangles change, but the final area remains the same. This is just because we are integrating an even function on an interval symmetric about 0. We should not expect this to happen in general. If we set t equals 0.5, we would be calculating the midpoint Riemann sum. We can go further and pick any value between 0 and 1 and get a new Riemann sum. Values that are closer to 0 evaluate closer to the left endpoint, and values that are closer to 1 evaluate closer to the right endpoint. Notice that every rectangle is being evaluated in the same position on each subinterval. What happens if we pick values that are smaller than 0 or greater than 1? The spreadsheet will continue to give us values, but they won't make sense as a Riemann sum. The problem is that if we pick values outside of the interval 0 to 1, we will get a point outside of the subinterval. This means that the area of the rectangle being drawn no longer corresponds to a value of the function in the interval. The values are coming from outside the interval, and that messes everything up. In the next video, we'll change the spreadsheet so that it will check the value of the parameter. We'll make it so that if we give it a value in the interval 0 to 1, it will give us the Riemann sum with the same position on each subinterval. But if we give it a value outside of that interval, it will pick a random point in each subinterval.